Okay, today I'm going to lecture about a variation of non-experimental design that I uh, introduced before, that are named actually relational research. Uh, in typical textbooks of research methods, it is actually called correlational research, and as the term of correlation may be confused with some specific statistical methods like correlation coefficients, and it may be uh, limited to some kind of statistical modeling which limited to correlation matrices. Uh, because of these shortcomings, I decided to uh, name it relational research instead of correlational research. I provided four uh, subtitles and four variations for the relational research. The most simple one and the older that is actually correlation and regression methods that I recommend using SPSS because so user friendly to do the correlation research and regression analysis, including multiple regression analysis. Uh, as the correlation research is bivariate uh, relation, and it is just limited to bivariate variables, and it is only investigate the correlation between two variables and does not control for other competing variables. uh, Regression analysis and multi-regression analysis in a specific can be used for statistical control for other competing predictor variables. It's also uh, uh, recommend that SPSS employed for doing this analysis. As the theory in behavioral sciences, educational sciences, or human sciences in the most extensive domain of research, the variables and the relationship between variables are not uh, confined to direct relationships, uh, and correlation and multiple regression just investigate the direct relationship of the predictors and the criterion or dependent variables in the analysis. Uh, Other methods of statistical modeling called structure cohesion modeling developed to cover for these shortcomings. In the structure equation modeling, the indirect effects and indirect relationship between variables, either observed or latent variables, can be studied. And the other advantage of the structure equation modeling is to control for measurement error. In the traditional methods of correlation and multiple regression, the observed variables just using the regression equations, and it is supposed that the variables are reliable and the measurement error is zero. But the fact is that measurement error is not zero, and we have always measurement error in assessing latent variables and constructs in human science. So this opportunity is also provided in structural equation modeling, that we use latent factors or latent variables and measurement errors in terms of measurement models can be controlled. And controlling for the measurement error, we can investigate the relationship between latent scores in a model that either can investigate the direct relationship between the latent variables or indirect relationships or effects of the latent variables. A variety of software can be employed in this regard, using the most sophisticated one are the Law1 package, and some other user-friendly software like SmartPLS that is suitable for structure cohesion modeling at item levels of questionnaires and scales. The AIMS, that is a complementary software for SPSS, and Mistral, actually the Mistral software that provide you with some models, including confirmatory factor analysis, path analysis, or regression on path analysis with latent variables. So in all of this software, we can do these analysis, the CFA, the path analysis, and the actually some may call it SEM, or it is precise to say that regression or path analysis with latent variables. All of this software can do this. We have also models that are not limited to one level of measurement. For example, in other measurement levels, we have, in other methods, we just measure variables and construct or either observe or latent variables in one level. In the, for example, supposing schools in a district, students can be actually are nested into classes, and classes are nested into schools. So we can do a three-level analysis. So we have some variables in the level of students, educational or psychological variables or constructs. We have also variables and constructs in the level of class. Um, the variables related to the teacher of the class, the educational or psychological variables, and the properties of the class, for example, size of the student enrolled in the class, uh, are the variables related to the class level. We have also a school level variables. All of the variables related to the school principals and administrator are related to the school level variables and constructs, and the demographic characteristics of the school or social status, socio-demographic status, actually of the whole school is also considered a school level variable. So we can conclude that there are different variables can be modeled, but they are in different levels of measurement. They may be in the student's level, they may be in class level, or maybe in school level. So we need a model that can analyze the effect of or the relationship of the higher level variables on the actually lower level variables. For example, the variables of the school and class levels can affect the variables of the student. Multi-level modeling methods using R are appropriate in this regard. We may have multi-regression, that is a multi-level one of the regression analysis. So we have a multi-level regression analysis. We may also have structure equation modeling that is in a multi-level mode. So the most sophisticated variation of this analysis could be a multi-level or multi-level structure equation modeling that package like Lavon can do this on our platform software. And at last, we have some relationships in a multivariate mode, in a network analysis mode, that the variables could be nominal or ordinal. In the previous three kinds of models, the dependent or the indigenous or the criterion variables are continuous and are in interval or ratio of measurement. But in so many occasions, you may have variables that are actually discrete. The discrete variables are variables that are in nominal or ordinal measurement scale. So multivariate discrete data analysis that actually provide you with the relationship network of the discrete variables can help you to understand and investigate the relationship of the nominal or ordinal variables together in a network manner, and we like the other kind of modeling we may want to investigate the direct and indirect relationships between among actually discrete variables which measure in nominal or ordinal scales. Some user-friendly software like SPSS can do multivariate discrete data analysis, but some are packets provide you with multivariate discrete analysis and provide you with some networks that show you the relationships between variables among variables. So R is preferred in this situation. So as you can see in the relational research, with these variations help you to model the relationships between so many variables together simultaneously, either quantitative or discrete variables can be analyzed in this kind of statistical model. Okay, this is our lesson today. We will talk about psychometrics methods as another non-experimental quantitative methods in the later upcoming class. Bye.